Welcome. So yeah, we have about 50 minutes to talk about IoT, and there's lots of IoT at this conference, which is great. And this talk hopefully is going to be very practical, giving you some pointers for you to basically know what's available in the open source ecosystem for building IoT solutions. But even before that, maybe give some background about basically the typical IoT architectures so that you understand why you would need a particular piece of software in the first place. Just a refresher so that we're all on the same page. Although I have cool toys and hopefully a cool demo here, I would like to remind everyone that IoT is not about like creating a connected thing just for the sake of creating some gadget like a connected dog collar or whatever crappy sometimes gadgets. It's really hopefully about thinking about data that you would like to collect so that you can start building applications and making value basically out of the data. Value not necessarily like financial value and money, but more like creating new knowledge, maybe by analyzing the data, and yeah, things like that. And so how will you collect the data? Yes, you will need a device at some point. And the challenge will be, and this is the whole point of IoT, what's required for bridging those devices to the IoT. Is this good old internet? Maybe, actually, in some cases. And sometimes you might require some like new functionality that's really specific to IoT and for which basically new software needs to be invented, and hopefully people will have done that before you in the open source ecosystem. So the physical world, that's really the devices. So what I call the devices, the constraint devices, usually the sensors, the actuators, typically not capable of accessing the internet directly, which is why in many IoT architectures you will see gateways, keeping in mind, and especially here in Sweden, here at Jfokus, you hear a lot about wireless sensor networks, which is a great technology, right? And in that case, in some cases, you would have the capability of having what I would call a constraint device that's effectively in between a device and the gateway. Let's call it a smart device. Because, well, it has direct internet connectivity. Not saying that it has all the features that what a gateway would have, and we'll see in a few minutes what I put in the gateway bucket. But yeah, some devices might be able to connect directly to the internet. And what do you do when you connect your devices or your gateways to the internet? You send data to so-called IoT cloud platform. So probably like you would think a good old database where you store all the sensor data, etc., so that at some point people will be able to access the data via some kind of APIs to build their apps. There's more to put in the IoT cloud, right? If you are building an IoT solution today and you're focusing mostly on the data, on the application data, you might be doing something wrong. There is more to do, especially in terms of device management. All those billions, thousands of devices, at least in the field, you need to manage them. You need to keep their software up to date, things like that. So that's why the IoT cloud might have some functionality that's really specific to IoT. Just, again, making sure that we sort of on the same page in terms of what's a device, what's a gateway, etc. The device is really constrained. Like physically, it's a constrained device, limited processing power, usually limited battery life, like you will be battery powered. So all the choices that are being made at the device level will have an impact at the software level as well. Like you have very little room for putting your software in there. So the software stack that you're going to use, whether it's something that's like straight off the manufacturer or that you complement with some additional libraries, this is going to be very, very specialized. So it has impacts in terms of like maybe the languages that you're going to target, and just generally in terms of features that are going to be available at the device level. The gateway is sort of a device on steroid. We've already sort of mentioned that when talking about the wireless sensor networks. The gateway is really here to provide the connectivity, right, to your equipment, to your devices, and because the gateway is usually going to be something that's fairly capable in terms of processing power, we will basically start being able to do things like edge analytics, edge computing. That is, the gateway sees and manages, say, 10 devices. Maybe the gateway will collect data from these devices like maybe every second, but consolidate the data, clean up the data, and report back to the IoT cloud only every minute or so. So that's the gateway. Yeah, and a router on steroids, let's say, an internet router on steroids. And on the cloud platform, yes, it's about like storing the data, for sure, but there's something to really keep in mind is that you really want to be able to scale your solution. It needs to be ready to ingest data coming from more and more devices. So basically all the cloud components for your IoT platform will need to be cloud native, right? And maybe your cloud platform is going to be AWS IoT and Azure IoT, in which case some of the things that I will say today will still be relevant in terms of functionality that's needed in the cloud. Yeah, I will certainly cover that. But my point is more what's available in open source for you to basically not have to depend on commercial vendors. And this is also true for the devices and the gateways, right? This is the whole point. So your platform needs to be able to scale. So we're probably going to talk about Docker containers and Kubernetes and whatnot. You need to be able to integrate with existing legacy systems, and you need to be able to enable data analytics. So let's start with a demo and maybe a more concrete example of, to my point earlier, rather than like starting with my choice and figure out what I could do, I start with my use case. My use case is I'm FedEx or I'm UPS, and I want to provide a solution to my customers and to myself, probably, as FedEx or UPS, to be able to track valuable parcels. Like, think of this box as containing Mona Lisa, maybe, right, or very expensive food. And I want to be able to tell my customer, you know what, we took this from point A to point B, and never did the temperature go above a particular threshold. Or if it did, at least you will receive an alert, or this will be logged. And maybe also based on all the metrics that will be collected, and the humidity and whatnot, maybe step 2 will be, you know what, we're going to use this data to optimize the routing of the trucks, depending on how, like if we have goods that are about to get spoiled, we may want to deliver them earlier and stuff like that. So that's kind of the use case. And at the end of the day, what I want to provide my customers with, and or the people in charge of operating all the trucks, is some kind of UI like this, right? Where, let me try and zoom just a little bit. All my vehicles. I want the list of all my vehicles. For each vehicle, where is it on the map? So here, obviously, this is simulated data. I want to know all the shipments that are in my truck, and I want to access the live telemetry. That's at least, that's the minimum. Ideally, there's also alerts, like if something goes wrong and then maybe an SMS gets sent to someone. But at least there's that. And this is live telemetry data. So in the room, or at least in the box, it's 23 Celsius. The humidity is pretty low. Pressure. Or how about the light? What if I open up the box? Let's say this is something that's sensitive to light. What's going to happen? I need to actually put it right in the light. Oops, it turns orange, red. It's probably like there's some kind of alert, right? So you've probably seen that there's actually a sensor in the box. So that's the beginning, basically, of how the solution has been implemented. Let's see in a bit more details what kind of software is involved and the way this particular proof of concept, if you will, has been implemented. So it starts with the devices, right? And so sensing the temperature, the humidity, etc. This needs to be done with a sensor that's as cheap as possible because, well, there's probably hundreds, thousands of parcels every day that go through FedEx and UPS, etc. So if each sensor is like 100 euros, it's not going to work. So the sensor needs to be battery powered, fairly constrained, and will probably not directly use internet connectivity, right? It's unlikely that you want to put, say, a SIM card in each and every parcel. Not even speaking about the sensors getting stolen, right? So the sensor in our solution is a off-the-shelf sensor tag, it's from Texas Instruments, and it's a Bluetooth low energy sensor beacon, if you will. So that's basically just enough for, even if with your smartphone, you could actually access the temperature, and it's really easy. It's standard Bluetooth low energy profiles. So we have the data. We just need to send it to the cloud somehow. So our assumption is that all the trucks that FedEx or UPS are driving will have connectivity, and just exactly like this, except it would probably be a more ruggedized solution, and it's not at scale. It would be funny though to have the trucks with a super huge board on top of. So the gateway is basically a Linux device, like Raspberry Pi-ish kind of device. In our case, we use a board from Samsung, the Samsung Arctic, and this runs Linux and this runs Eclipse Cora, and we will see in a few minutes what's effectively what is Cora and what's the software we run. But basically the idea is that we want something that on one end is able to talk with the sensors over Zigbee, Bluetooth and whatnot, take the data from the sensors, and then on the other end, here I'm using Ethernet because it's more reliable, but very likely on the truck there would be a cellular modem as part of the gateway, and that's how the connectivity is provided. And then we have connectivity, which means that we are pretty much, it's good old internet, so we can push data to our cloud. We could certainly push data directly into maybe an InfluxDB database or something like that, but like I said earlier, it's really more than just the data that we care about. We want to be able to operate the solution on the long run. So we send the data using the MQTT protocol to Kapua, and Kapua is basically the equivalent of AWS IoT or Azure or IBM, the IoT solution from IBM. And then, well, basically we store the data, but we also have a solution to manage the software, to remotely maybe reboot the gateways if something goes wrong, monitor the signal strength of the cellular connectivity layer, etc. And basically, Kapua, once the data is stored, exposes APIs, good old REST APIs. And this is how, at the end of the day, I built the dashboard with basically just HTML and JavaScript and CSS, and you just get the data of the backend, right? Or you can use maybe Kapua directly. It already has default dashboards, just like you would have if you go to your AWS IoT admin console. You can also do things there, right? You might not actually want to customize anything. So let's dive a bit deeper into what's in each stack, right? The device, constraint device, the gateway, and the cloud platform. And the wall point, and I already mentioned, sure, you can use commercial solutions, and functionally, this will very likely be equivalent, except that if this is if the software you're basing your solution on top of is not based on open source and open standards as well, like the MQTT protocol and things like that, you will have lots of coupling between your gateway and your cloud backend. If you buy a gateway from a vendor that has a partnership with AWS IoT, well, maybe, and sorry if there's anyone from AWS, I really have nothing against those solutions, right? It's just trying to make you understand why sometimes open source might be a good idea. If the gateway relies on some APIs that are like AWS specific, it might be a challenge, like you will have to use a protocol X, and if AWS is the only vendor that provides support for this protocol, well, you will have to bet all your business basically on this. And same, say, at the device level, if you use an SDK from a silicon vendor that comes with a specific protocol and you realize that you would be better off with, say, CoAP, and CoAP isn't supported, well, the SDK is a black box, so there's just no way you're going to be able to use your protocol of choice. Same for the platform independence. Again, back to the example of the silicon vendor. If you start like creating an embedded application and use some hardware abstraction layer, that's not really a hardware abstraction layer because it's, I don't know, TI specific or whatever else specific, it might be a challenge once you realize that there is a chip from a competitor that has a better pricing or better battery consumption. You will have to rewrite your embedded software. So I think you get the point, right? So at Eclipse, and in many other communities, by the way, like there's also stuff like just off GitHub, you would find really cool open source IoT projects as well. The Linux Foundation certainly does some stuff as well. I just want to sort of use Eclipse as an excuse to show some examples of what's effectively in the three stacks. So Eclipse is a global open source community. We have more than 250 projects, and all the way from the Eclipse IDE to software for autonomous driving, scientific software, all things modeling, runtime technology. Like you maybe don't realize if you just call Jetty, but it's Eclipse Jetty, Vertex, and etc., etc. And we have a lot around IoT, 30 different projects, lots of code, a very active community, hundreds of developers. And yeah, we build software for IoT. Software that you can see and think of as just building blocks, libraries for IoT. And actually, there were already a couple talks this week about, for example, Eclipse Paho. If you just need an MQTT implementation, you can use Eclipse Paho, right? Or you can use Eclipse Californium if you want a CoAP implementation. But at some point, like, yes, it's great to have lots of libraries to do the job, but ideally, when you build your server, you get a recipe, basically, or a bunch of Docker containers, call it however you want, so that you don't have to rebuild and to integrate all the server stack yourself, right? If you will require a time series database and a device registry for managing all the inventory of your devices, and a layer for doing and dealing with the identification and the security of all the devices, you want someone to ideally do the integration for you, right? So for the constraint devices, and I won't focus that much actually on that, especially since there might be better options, quite frankly, out of the Eclipse ecosystem, or at least we don't have what I would call a stack. For example, we don't have a real-time operating system for IoT, like something like Contiki would be, or FreeRTOS could be, right? But yet, there's some interesting building blocks that you can get from Eclipse. If you care about doing MQTT in a very constrained environment, Paho has a C implementation of the MQTT protocol. If you care, and you should, about doing device management in the form of being able to effectively upgrade the firmware of your constrained devices and things like that, Eclipse Wakayama is the reference implementation of the lightweight M2M standard. And Wakayama is something that's, for example, used by Samsung or Sierra Wireless in their modules, in their SoCs, in their cellular modems. They actually put Wakayama in there so that anyone, whatever their cloud platform is, as long as it supports lightweight M2M, they can deploy new firmware upgrades, they can monitor the health, basically, of a fleet of constrained devices. A more interesting part is of the end-to-end solution is what you do and what you need at the gateway level. You may have heard about Eclipse Cora in the past. It's basically a Java-based framework that you deploy on top of Linux or Windows, actually. And basically, you take Cora and you put it in industrial gateways, right? Either gateways that are deployed on a shop floor in a factory, or maybe like in a truck, and the gateway will basically be, like I said earlier, an internet router on steroids. Comes with built-in support for all things network management. So that is, you want to use the gateway as a way for your solution to be connected all the time, ideally, right? So the gateway will have maybe Ethernet, Wi-Fi, and cellular. So you want to do things like set up the gateway so that it tries and get internet connectivity from the Ethernet link. But if Ethernet goes down, maybe you'll switch to Wi-Fi. If Wi-Fi goes down, you switch to cellular. And if this fails as well, you want the gateway to store data locally and to store all its settings so that whenever the connectivity comes back, you can forward all the data that you've stored, forward that to the internet, right? You want the gateway to also talk to your devices, right? It's not only about connecting to the internet, it's talking to your devices. The Cora would come with built-in support for lots of industrial field protocols like Modbus, CAN bus, Siemens S7, OPC UA, things like that you would require when you start interfacing industrial equipment. And last but not least, the Cora gateway is basically an application container. So, I mean, you have all support for all these protocols, but at some point you need to effectively build an app, right, that will take the data, maybe consolidate it, clean it up, and send it to the cloud. And so basically you can do that. So that's what you see at the very top, right? You can deploy your apps based on the Cora applications, and do your stuff. So how does it look like if we switch back to the demo I was showing earlier? So just refreshing and zooming just a little bit. So this is me using my web browser to manage my gateway, just like you would at home with your DSL router. And so assuming that I am in the field, basically, and next to the gateway, it's very likely that I can directly access to the IP address of my gateway, and start doing things like, oh, what's the status of my gateway? What is the URL of the MQTT server I am connected to? How long? What are the different internet interfaces that are configured? What's my position? Should I have a GPS device, a GPS dongle? I plugged it on the gateway, and automatically it starts, and it just works. Like, it's already built into Cora. The position will be gathered and actually will also be reported to the cloud every minute or so. So geolocation is already part of the solution. More information regarding the device. What is what version of Java am I running? And actually, I'm surprised. I thought I was running Zulu embedded, since that's part of the demo. But I guess I changed the default Java settings. What version of Linux? What are all the software components that are running? Maybe I want to stop some of them, to upgrade them, etc. What if I want to execute remote shell commands? I don't need to SSH or anything. I can do it just from here. Managing the network, like I was saying earlier. I want my WLAN to be, I don't know, an access point and blah, blah, blah. I can do things like that. I don't want to save the settings. And so that's basically a router, right? But it starts becoming IoT when, one, I use, do you want to Discord them? Yes, I want. It starts becoming IoT when I go and configure my gateway so that it knows about a particular MQTT backend. And so in my case, it's Kapua. We'll come to that later. And I basically tell my gateway please automatically connect to the MQTT server at boot time, and please try and keep the communication and the connection open, right? That's going to be one job that Cora does actually very right, is try and keep the communication open. And once we know that whatever happens, we should get like this MQTT link to the backend, we can start building apps. And building apps is basically you using the Java and OSGI actually APIs of Cora, develop your own services, your own components, your own plugins, package them, and deploy them onto the gateway. And I have at least one app in my solution, which is the app in charge of sending data to my IoT cloud. The app can suddenly expose parameters that's kind of built into Cora, that any application that you build may expose settings, strings, integers, combo boxes. Like it's fairly like simply typed kind of parameters, but just enough so that you can create a UI, a generic UI. And maybe here I want to change what's the whitelist of devices my solution talks to. I want to disable the analysis of the temperature, etc. And you can see that there's lots of other services that are built into Cora, and that can be configured as well. I want to change what NTP server I use for getting the time, etc., etc. You can actually also do visual programming, similar to what you would do with Node-RED, for example. And so I could very well imagine, rather than writing Java code for talking to my Bluetooth low energy sensor, I could actually also do this visually and more like configuring my IoT app rather than writing code, basically. So that's for Cora. If you care more about home automation, there is a full stack for smart home. This is called Eclipse Smart Home, so you should check it out. And if I remember correctly, in previous years, there were talks about Eclipse Smart Home here at this conference, so you can certainly find the material online. Moving on to the cloud and trying to show what's there. Building blocks wise, there is some very interesting bits and components for all things device management, and more specifically, when you have 1,000 devices, 1,000 gateways, and you want to push a new software upgrade, how do you do that so that, one, you don't have all your devices calling home at the same time and downloading 100 megabytes worth of firmware and basically killing your network at the same time, and maybe killing also your invoice from your cellular carrier. So there's that, but there's also, if all your 1,000 devices download the firmware at the same time and there is a bug in the firmware, maybe you're going to break all your devices at the same time. So Eclipse Hogbit is basically a stack, or a library rather, for dealing with the software upgrade campaigns and rollouts. So how do you model your upgrade campaign so that it's going to happen over the course of maybe 7 days, and as soon as there is more than 1% of the devices that report that basically they're gone and the upgrade failed, you may want to upgrade to cancel the upgrade campaign altogether. So that's something that Hogbit does, and it's protocol agnostic. You can use it to manage rollouts of new Docker images, rollouts of new shell scripts, of new CSV files to configure your devices. Can be anything. A good companion to Hogbit could be Eclipse Leshan, which is basically the lightweight M2M implementation on the server side, and so you can certainly do that. And so Hogbit provides all the generic infrastructure to model what's a software artifact in your world, what are the dependencies between the artifacts, provide all the fancy visual dashboards with the pie charts to see how your upgrade campaigns are doing, etc. And then by means of the Hogbit APIs, you can develop custom agents so that you effectively do upgrades over like Docker upgrades or upgrades for Android devices. There are people who extended Hogbit for managing custom-built Android devices, etc., etc. But that's really just one thing, right? That's building blocks for device management. This might not be enough when you start building a full-blown IoT backend where device management is one, but you also want to store your data in some kind of time series database. You want to authenticate the devices that go and come and talk to your solution. But how do you share the identity of the devices between the device management part of the solution and the data store? Is there some common ground there, or do you need to sort of integrate the whole stuff yourself? Yes, there is a common ground, and that's called Eclipse Cora. So Cora is basically defining all the microservices that are required for IoT. You need a device registry, you need a messaging layer, you need a way to store metadata for the devices, you need a way to store the time series data for the devices, etc., etc. And it provides sort of default implementations, if you will, of those services. Some of them are like come from Cora, or some of them can be other projects, right? If you want to, for example, the data store in Cora, by default, it's Elasticsearch. If you want to replace it with InfluxDB, you can do that as long as you provide the wrapper, if you will. And no matter what you do, at the end of the day, the Cora web console, web UI, web dashboard will be able to show you what's in the data store. For managing the REST APIs that allow you to interact with your devices, Cora provides something, but you can decide that you want more, and you want something that's typically called the digital twin, and in which case you would integrate Ditto within Cora. And what does this mean when you do digital twin is that no matter whether the device is physically there and you're physically connected to the device from your cloud or not, you can still interact with it. Think about like switching on the light. Even if the device is not there and not like directly turning on the light, you might still be able to interact with a digital twin. And maybe what you will do is turn the light on and off immediately. And what happens is that like you can still have your app react as if the light bulb was there, but in practice, this will only happen on the digital twin, and whenever the light effectively connects again, it will realize that, well, there's nothing to do because, well, basically it was neutral, right, the action that's been performed on the digital twin. And for the connectivity, Hono is the component that helps with basically ingesting data coming from different protocols, HTTP, MQTT, CoAP, and whatnot, and make sure that all the apps in the backend can all rely on a single consistent telemetry API that's basically AMQP based, and you don't have to deal with the complexity of all the protocols. And Cora, so the whole platform, is cloud native, and you can deploy it on Kubernetes, like straight Kubernetes, or on OpenShift, which is what's done in the context of the asset tracking demo. If I were to open up my OpenShift console, I can briefly show you that I have lots of things deployed in my backend. One is my web application, actually, the dashboard and that we've seen earlier with the telemetry, etc. So that's the end user app that runs basically in the same cluster where the rest of my IoT solution is being deployed. Cora API, this is one container. The SQL, MySQL, actually, database for storing all the metadata of the trucks, etc. This is one container. Should I need more, I can scale up. The MQTT broker, where all the telemetry is being sent. Same. If I want more, I can scale up. The Elasticsearch time series database for all the telemetry data that's being stored. One more. The console, the web console for actually interacting with my devices and monitor and operate them. That's more, etc., etc. I can also simulate the data. That's one more container. So this is what you get basically if you download Cabé and basically deploy it in your OpenShift cluster. And what you get at the end of the day is a web UI, well, also that can be used to basically, I need to switch to a different account, a web UI that I can use to monitor my devices. I have my simulated truck as well as my real actual truck. All the things we see here are very similar to what we were seeing earlier when directly talking to the gateway, right? Same for the bundles. I want to manage the bundles. This time, I'm really doing it over the air, right? Would I have thousands of those? I could operate them. I don't need to be physically next to the devices as long as they're connected to the internet. I can manage them. I can tune the configuration. This should sound familiar, right? Disabling the thermometer. Well, you know what? I'm going to actually do it. Disable the monitoring of the temperature. So from the cloud, I tell my gateway in the field that it should start behaving differently. If I go here, let's see how it goes. So the luminosity should still be there. Yeah, luminosity changes. Humidity probably as well. Temperature, not so much. And to double check, we could also go here in the Cora, in the admin UI. I think I need to refresh actually, which is not ideal. There we go. The setting has effectively been changed. I can operate my solution. I can have raw access to the data store. What's in my data store coming from all the devices? Manage the users. Create a new John Doe user that will be only able to read telemetry data with his credentials. And maybe I create a new user, Bob, and Bob only can deploy new software, right? For example, this is all part of the of Cabé, right? All the permissions, etc., etc. The hierarchy of accounts. FedEx has some local division in Europe and then in France and blah, blah, blah. All this hierarchy can be managed as well. So that is pretty cool. So wrapping up with a few more things, and hopefully we can also take some seconds for questions. But I mean, there's a break, so we can discuss more. This is being used in the industry today, right? So this is the annual huge Bosch conference, and the next one is actually coming up in just a few weeks. Bosch has an IoT suite. They call that the Bosch IoT suite. This is based on Hogbit, on Hono, on Ditto, etc., etc. Yourtech, Red Hat, those guys, they have commercial products based on Eclipse IoT. Samsung, Sierra OLS, same. I mentioned what they do with lightweight M2M. So this is really nice to see that those companies actually realize that they want to build their solution on top of open source rather than relying on the commercial, on the giants that I mentioned earlier. They don't want to bet their multi-billion-dollar business on commercial clouds and commercial stacks, right? At Eclipse, we do more than just the code. If you want to sort of stay in touch with what's happening in IoT, we have a virtual IoT meetup, just like the virtual jug, except it's for IoT. Highly encourage you guys to join the group. And every 2 weeks, basically, we have webinars, and you can learn a lot there. We do developer challenges and contests, basically. We have the IoT marketplace where you can get new plugins for Eclipse Smart Home or for Eclipse Cora. They are being promoted and listed there, and you can directly, basically, drag and drop them on Cora, basically, and install new functionality. We do test beds. So this is actually more than a demo in practice. You may remember that the diagram I was showing, Samsung was showing up there, Eurotech was showing up, Azul, Red Hat. Those are vendors, right? And so we are an open source foundation, an open source community, and we are very much vendor neutral, and there's no doubt about that. But for us, success is not only people use the projects, but people use them to build commercial products and to sell their expertise. And it turns out that if you want to take this to the market, you will need someone that can help you build a hardware gateway that fits with your trucks. You want someone that can provide you with SLAs for the cloud and for operating the cloud. So at some point, yes, you will run open source software in the cloud, but you will have a partner that will help you for a given amount of money, help you make sure that the cloud is up and running. Or you can do it yourself. I mean, there's no problem about that. So we are very interested in, and maybe some of you in the room are building stuff on top of open source software and open source software from Eclipse IoT. If you want to partner with us, basically, and with other commercial vendors to demonstrate and to show and to tell your story, I'd be happy to hear from you. And in the meantime, you can check out iot.eclipse.org/testbeds. You will find, we basically publish all the instructions for people to replicate the testbed. So all the instructions for this guy here is on GitHub, or on GitHub, and same for our industrial IoT, Industry 4.0 testbed. That's available as well, and we are working on putting together more testbeds. One more thing, since it's a Java conference here, I wanted to make sure to spend just like a quick reminder that, well, Eclipse is more than IoT, but that I think you know, and it's the IDE, etc., etc. And more recently, Eclipse is becoming the home for all things Java EE, right? Oracle is basically bringing the whole Java EE story to Eclipse. It's called EE4J, and there's going to be basically open source projects for all like all the implementations of the GSRs. They are in the process of moving to Eclipse. Some of them already have, actually. And even like the specification process will be done in a completely vendor-neutral environment, which is the Eclipse Foundation, right? So, yeah, Glassfish has already started moving, I believe. And I think in total it's going to be something like 50 new open source projects at Eclipse. So I'm not that knowledgeable about the whole story, but if you have questions, I'd be happy to point you to who can answer them. Something that might be more relevant to IoT, actually, but that's a really cool new addition to the Eclipse portfolio is going to be deep learning for J. So this is basically the leading stack for doing deep learning in Java, and it's really cool in that it's it's really fast. It can leverage things like GPUs and or Hadoop clusters for doing like if you need lots of processing power for training your models, you can do that. And like they have a huge community, lots of examples that are available for all things image recognition, natural language processing, etc., etc. And I think for IoT, it's going to be pretty interesting to see what happens when you start running deep learning 4J at the edge, and you can start like being really smart in the way you collect the data, in the way you report back to the server, rather than sending lots of data, lots of telemetry data to the server so that it can be further analyzed. Maybe you analyze it at the edge, and the only thing you care about is sending a very simple piece of information, which is, I don't know, like the health, the overall health of the shop floor, and that's really all you need at the end when you maybe in your use case, right? Looks like I forgot one slide, but if you run really fast, you can go to the next room, to the room next door, and learn about OpenJ9. This is also really cool, I think. So OpenJ9 is basically IBM's J9 JVM, which has been brought to Eclipse, and it's like 20 years, well, maybe not 20 years, but decades, let's say, of expertise from IBM in building high-performance JVMs, high-performance garbage collectors. So basically, what OpenJ9 is a replacement for hotspot, right? In open source under a business-friendly open source license, and it runs. So right now, it runs really well on x86 architecture, but there's also like they are working on the ARM port, and actually I have OpenJ9 running on my Raspberry Pi, and I will be looking at sort of how it compares to OpenJDK and to Zulu, but it's pretty interesting to see that we have that coming as well. And that's what I had for you. Join us, get involved. IoT.eclipse.org is the main website. Check out the projects. Don't be shy and show up on the mailing list. Reporting bug fixes or feature requests is always valuable, as you know, in open source. The virtual IoT meetup I mentioned. If you're working on some cool open source projects of your own and you think this might be a good fit, this might be a good home, we should talk. And I would be very grateful if you would spend a few minutes, 8 minutes probably of your time filling out our IoT developer survey every year for the past 3 years. We ask developers, IoT developers, how they approach IoT, what programming languages they use, what is the cloud backend that they build their solution on top of. Is this AWS IoT? Is this custom? Is this Azure, etc., etc.? This is really useful for us to know what's missing, basically, in terms maybe of open source components. What are the leading companies out there? And usually, this is something that people find very valuable. So if you have a few minutes, that would be awesome if you could contribute. And this is where and how to find me. My blog, there's some cool demos that I try to post. That's what I had for you. Any questions? Thank you.
Any questions?
So the slides will be online. I know there's lots of sort of name dropping and like lots of project names that might be hard to remember. Don't worry, you'll find the slides online.
No questions? Well, thank you very much.
Thank you.
Thank you, Benjamin.